Well, hey there, sevens and eights. So I have an activity for you guys today that I usually do with the eighth graders, but I realized it can serve both of our purposes. Like I can use it for different ideas in both of your classes. So good. This is an investigation. It's a geometry investigation, and if you have tools like a compass and a ruler, then you will use them. If you don't, I have some online tools I can show you that you can also use. I think the online tools, well, they're nice for some reasons, and you'll see they're kind of difficult for some reasons. So to give you an idea of some types of problems I might give you today, I'd say like, let's construct a triangle with side lengths of 2 centimeters, 4 centimeters, and 8 centimeters. Well, that seems really easy. I'll just move my compass over here because I don't really need it. Let's look at using this ruler. I'm going to assume these are millimeters because that's the way rulers usually are. It's just not marked. It should say millimeters somewhere on here. I'm probably inches down here, but good. So I want 2 centimeters. 2 centimeters is like that. And then just because I have software, I can do nice things like just leave that there, come down and go 4 centimeters. And then I can move this down again and go 8 centimeters. So these are our side lengths. Oh, and then I can just take this, and I think I can just kind of try to piece these together. You see, rotate, good, good, good. So let's say I have something like this, and then I try to put this side in, and we can see in this case that side is like way, way too long. So okay, I'm gonna go ahead and rotate this side out like that. Good, and now I'm going to try to connect this guy up. Running out of space. So if you're doing things with software, it might work like this. If you're doing things with rulers, it's harder kind of, but I'll give you a tip as soon as I try to work this one out. So if I match this up, you can see this side is still way, way too long over here. If I try to lay this out completely, so these guys almost go straight, then I can see this side is still way, way too long. So what's the problem with this? Like, why is it not working out? And I can quickly become convinced of something. In this case, I would say I am convinced that given 3 side lengths, if one is longer than the others combined, it's impossible to form a triangle. So good, that makes sense. And it makes sense here, like 2 plus 4 is 6, which means if I lay this out completely, those will be 6 in length, and this one will be 8. It's way too big. So I just become convinced that if I look at the side lengths now, I could tell right away if I can make a triangle, because 2 and 4 are 6, it's too short. If it were like, whatever, 3 and 7 are 10, that's longer than 8, then that would be fine. But I can become convinced of a theorem like this, a theorem just being something that is always true about triangles. Given the 3 side lengths, if one of them is longer than the others combined, that should be plural, then it's impossible to form a triangle. Great, so your investigations today are going to be investigations about congruency. So a triangle congruency occurs when, given some information, there's exactly one triangle that can be constructed. So one trivial example is if we have these angles and these side lengths, that triangle, just as a quick drawing, it looks like this. So we have like 45, 45, and 90, and this should be 1 and 1. So that my drawing is a little bit off, but it's fine. This side ends up being root 2, and it doesn't matter if these are centimeters or meters or whatever. So if I try to make a different triangle with that information, well, it still has to be 45, 45, 90. These sides still have to be 1 and 1 because that was the given information. This side still has to be root 2, and it doesn't matter what triangle I draw. These triangles are congruent to each other. This is the symbol we use for congruency. It's like an equals with a little wave on top. So given those 6 pieces of information, we could construct 1,000 triangles, but they would all be congruent to each other, just like these two here, even though my drawings are bad. And that's because congruent triangles are defined by having the same angles and side lengths. So these have the same angles and side lengths. So they have to be congruent, but that's what we started with. So it was obvious that was going to happen in this case. In our test, though, it's going to be a little more difficult. We have information given. We're going to construct a triangle and decide if that information makes a congruence. Let's look at the first one. So first one we're going to look at is side angle side. I'll show you what I mean in the end. We're going to draw a triangle below, given the two side lengths and the angle between them. The angle has to be in the middle in this case, which makes sense. The angle here is in the middle between the sides. So we have two side lengths and the angle between them. Then we'll decide whether it's possible to make different triangles or if they're all the exact same triangle, and that makes side angle side a congruence. So let's go ahead and look at it. I'm not going to use the same tools I was using here. You're welcome to use physical tools if you have them and do it on the paper, or you can use the GeoGebra tools I'll use. So I'll leave a link to it, but just to note, if you Google the word GeoGebra, you'll be sent to this site. And if I just go here, I want more apps. I want geometry app because we're looking at geometry right now. So when I click that, it opens. And I get this nice geometry tool that you guys haven't seen before. These are some of the basic tools. I can click more, and there's a whole lot more, and we'll need them. First, we want triangles. Triangles are three-sided polygons. So I'm going to make a triangle here. Great. But in our case, the triangle we want side lengths 3 centimeters and 4 centimeters and an angle of 20 degrees. So that means in GeoGebra, I need to measure some of these things to make sure it works out. So we do have measuring tools down here. We want to measure a distance. So I'll measure A, B, and I'll measure A, C. So we want those to be 3 centimeters and 4 centimeters. Both of them are too long right now. And then I want the angle between them. So I'm going to click like that. So notice I went C, A, B. So the middle of the angle has to come in the middle, the vertex of the angle. So now I want to hit exactly these. I want to be 3 centimeters, 4 centimeters, and 20 degrees between those two. So if I come back here and look, not that tool, this one. I want 4 centimeters. Okay, that part is easy. Here's the hard part. Now I want 3 centimeters and 20 degrees. So I have to do those simultaneously. Sometimes it's easy, and sometimes it's crazy, crazy difficult. Okay, there I'm at 3 centimeters, but I need a smaller angle. I want to hit 20 degrees. 20.1 is close enough that I can see what's going for it. So now that we have that triangle drawn, I want you to go back here and copy, what does that triangle look like? I know that you have used digital tools to draw it, so just give me a decent idea of what it looks like. And then I want you to see, can you come up with a different one? So is there any way I could use this information and come up with a different triangle? Well, I mean, I would have to change the length of this in order to, like, I guess we have a triangle over here, but that triangle is congruent. So if I could use the same information and make a triangle like this triangle out here or something like that, then we would have a different triangle that I would copy here. If I can't come up with a different triangle, then just come back here and say that this is impossible. I can't come up with a different triangle. We only have the one. And if you can't come up with a different one, then side angle side is a congruency. It means given this information, it's always the same triangle. So then I want you to go through the rest. Side, 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 I'll give you 3 side lengths. You try to make a triangle, see if you can make a different one, and then tell me, is it a congruency? Is basically like, could you make a second one, or were you not able to? And then same thing with some different characteristics. I assume this assignment will probably take multiple lessons. So we'll just talk about it today. I want you to get done what you get done, and just don't worry about the rest. And we will talk about it when I see you guys in the second lesson today. So good luck. See you guys soon.